Hello chemists, this is Ms. Placino and you are watching screencast 10.4 on dilutions. Today we're going to talk about how solutions are diluted to lower concentrations. This is a really, again, important skill for a chemist. When you order a solution from a chemical supplier, let's say you're going to order hydrochloric acid for your lab, it comes in its most concentrated form. For hydrochloric acid, that's about 12 molar. 12 molar HCl is extremely dangerous to work with, so it's kind of impractical to use it in the lab, except for very, very specific applications. So what you would need to do is dilute it to a lower concentration. We're going to talk a little bit about the formulas that you would use to do that, and we'll go through some practice problems. All right, so in order to make a dilution, you start with your stock solution. The stock solution is what we call that really concentrated solution that we need to dilute down. And in order to perform a dilution, or really make any solution for that matter, we use a specialized piece of glassware called a volumetric flask. Volumetric flasks look like this. We kind of have this bulb at the bottom, and then a long skinny neck. And a volumetric flask also has kind of a line etched in on it. And this is called a fill line. The reason we use volumetric flasks is because they are extremely precise. So this line that's been drawn on the volumetric flask, it's not placed there arbitrarily. It's because they took something else that was calibrated in this case to 500 milliliters. They poured it into the volumetric flask, they saw where the liquid level was, and then that line is etched on after the fact. So when you have the volume of the liquid in the volumetric flask perfectly filled to the fill line, most volumetric flasks are going to give you 2 places after the decimal point, at least the ones we use in lab. So this is an extremely precise piece of glassware. You really want to make sure that you don't break these in the lab, as they are expensive due to this degree of precision. To figure out how to make your dilution, in other words, how much stock solution do I take out, and then what, basically the total volume I need to dilute to, we're going to use this formula, M1V1 equals M2V2. You can find a variation of this on your reference table under titration for acids and bases. It says MAVA equals MBVB. I know it's not exactly the same, but you can use it as though it is exactly the same. Couple things to be careful with when using this formula. First off, make sure that you keep the stock solution on one side and your desired or diluted solution on the other. So I would say when you're first starting out, take the extra 2 seconds and just write stock and dilute. It only takes a moment, and it can potentially save you from making some really careless mistakes. The other thing is to be consistent with your units. M1 and M2, those are virtually always going to be in molarity, definitely in this class. Your volume can be in anything. It can be milliliters or liters, most likely, but it could be something like cups or pints or gallons. You just want to make sure that your units match. For example, if you are expressing the volume of the stock solution in milliliters, the volume of your diluted solution should also be in milliliters. If you're not consistent, you're going to be off by orders of magnitude. So really pay attention to units. And kind of here's how a dilution works. You take your full strength, your stock solution. You could take out a specific volume, and you're going to transfer it to a new volumetric flask and dilute. So in this case, we're doing what's called a 1 to 10 dilution. We took 1 milliliter, diluted it to a total volume of 10 milliliters. So our new solution is 1/10 as strong as the stock. I could continue doing this. I could take a milliliter and dilute, a milliliter, dilute, milliliter, and dilute. This is called a serial dilution. And I could keep getting to less and less concentrated diluted solutions. Or I could go directly from the stock solution to the least concentrated solution just by taking out, in this case, 1/10,000th of a milliliter. As you might imagine, that's really hard to measure, so this is why you do a serial dilution. But this picture really just kind of shows you what a dilution is. You go from a high concentration of solute in your solvent, and as you dilute, you get to a lower one. We're not going to worry about doing serial dilutions in this class, so we're just going to cut right to the chase. So from your stock to whatever the desired concentration is. Let's go ahead and take a look at some practice problems, maybe make it a little bit more practical. Discard. Okay, so we'll just start up at the top. You have a 6 molar solution of HCl. What volume would be used to make 500 milliliters of a 1.0 molar solution? Okay, this is definitely a dilution problem. So I'm going to write my formula. M1V1 equals M2V2. And just like I told you to do, I'm going to write stock on one side and diluted on the other. In this case, I'll just use S and D because I'm going to be that lazy. See, it doesn't take any time at all to straighten this out. So for my stock solution, the molarity, oh, I know it. I'm giving it at 6.0 molar. The volume, well, it's asking me what volume would be used, so I guess we're going to leave V1 as our variable. Okay, for the diluted stuff, I'm making a 1.0 molar solution, and I need 500 milliliters of that solution. And it doesn't really matter that I've chosen to work in milliliters. All that means is that the unit for the volume of my stock solution is going to be in milliliters. So hopefully this isn't very complicated algebra by this point in time. I can take 500, divide it by 6, and I end up with, I guess we can really only go to 2 sig figs, 83 milliliters of stock solution. Now, I'm guessing from a mathematical perspective, it's not really all that hard to follow what I did. But if we think about this from a what does this look like in the lab perspective, it might be a little bit more difficult to visualize. I'm going to have my container of 6.0 molar HCl. You can see I did not do very well in art class. I know that I want to make 500 milliliters. I'll put this in a volumetric flask of 1.0 molar. So there's the fill line. So what I would do is, using a tool like a graduated cylinder, for example, I would measure out 83 milliliters of my concentrated or my stock solution. I would transfer it into this 500 milliliter volumetric flask. So let's leave that as red. I'm just going to kind of make that like a little brick, even though it would be a liquid. And then I'm going to fill up to the fill line with water. Try to represent that with the blue squiggles. So I'll take my 83 milliliters, transfer it to my 500 milliliter volumetric flask, because that's the volume, the solution volume that I want to make. And then I'm going to dilute up to the 500 milliliter line using water. And that's it. That's how you do it. Let's walk through another practice problem just to make sure we've got the gist of it. Let's do number 2. If 25 milliliters of a 10 molar solution is diluted to a final volume of 600 milliliters, what is the molarity of the diluted solution? Okay, M1V1 equals M2V2. And I got my stock, and I've got my diluted. Let's see, I'm taking 25 milliliters of 10 molar solution. So I've got my stock information. It'll be consistent. 10.0 molar times 25 milliliters. I know that I'm diluting to a final volume of 600 milliliters, and it's asking me for the molarity, so we'll leave M2 as the variable. 600 milliliters is my final volume. Again, from a mathematical perspective, probably not too complicated. You guys have been doing algebra for a while. I've got 10 times 25 divided by 600. And to the correct number of sig figs, in this case, we'll use 2. This is a really common mistake that I see, and I want to take a minute to point it out. A lot of times students will give me this, M2 is equal to 0.42. Now you've done everything correct, and you know if you do this, I'm going to write on it -1, or now you know, units. And students tell me, no, see it's right here, molarity 2 is equal to 0.42. So I've told you the units. No, you haven't. When the letter M is on the left side of the equal sign, it is a variable. When the letter M shows up on the, well, I should say to the right of your calculated value, now it's a unit. It's important that you differentiate between the two. Don't get sloppy on your units. Take that extra second and literally just write the extra letter. It's not that hard to do, and it'll save you a lot of frustration as I kind of just bleed red all over your paper writing units and question marks. So please differentiate between the two. All right, that about wraps it up for today. It's a very straightforward formula to apply again and again and again. You've got plenty of practice. This last one down here, even though it's a little bit longer and more challenging, it's the same idea. As I always tell you, keep working with the practice problems. Make sure you feel comfortable with this. And thank you for tuning in. I hope you found this helpful.